Hello everyone, my name is Aliasgar Umatia. Today my topic is acid properties in ADBMS. To ensure the integrity and consistency of data during a transaction, the database system maintains four properties. These properties are widely known as acid properties. A. Atomicity. The entire transaction takes place at once or doesn't happen at all. C is equal to consistency. The database must be consistent before and after the transaction. I is equal to isolation. Multiple transactions occur independently without interference. Durability. The changes of a successful transaction occurs even if the system failures occurs. Atomicity. This property ensures that either all the operations of transaction reflect in a database or none. Either it executes completely or it doesn't. There shouldn't be a partial execution. Suppose account A has a balance of $400 and B has $700. Account A is transferring $100 to account B. This is a transaction that has two operations: A. Debiting $100 from A's balance, B. Crediting $100 to B's balance. Let's say first operation passed successfully while second failed. In this case, A's balance would be $300 while B would be having $700 instead of $800. This is unacceptable in a banking system. Either the transaction should fail without executing any of operation or it should process both the operation. The atomicity property ensures that there are two key operations are involved in a transaction to maintain the atomicity of a transaction. Rollback. If there is a failure in the transaction, abort the execution and roll back the changes made by transaction. Commit. If transaction executes successfully, commit the changes to the database. Consistency. Database must be in a consistent state before and after execution of the transaction. This ensures that there are no error in the database at any point of time. Application programmer is responsible for maintaining the consistency of a database. Consistency. The consistency property ensures that only valid data is written to a database. Before committing a transaction, consistency checks are performed to maintain database constraints and business rules. For example, a transaction crediting 5,000 to a bank account with a current balance of 3,000 is invalid if account has an overdraft limit of 1,000. The transaction violates consistency by exceeding the permissible account limit. Hence, it is blocked and abort. Consistency enforcement prevent data corruption and invalid entries. Only transaction abiding by consistency rules are committed to upholding data accuracy. Real world business constraints are modeled into database via consistency. Transferring $1,000 to B. A's initial balance is 2000. B's initial balance is 5000. Before the transaction, total of A plus B is equal to 2000 plus 5 is equal to $7,000. After the transaction, total of A plus B is equal to 1000 plus 6000 is equal to $7,000. There is no other transaction which change the value of A or B during execution of a T. Then the new values of A and B will be 1000 and 6000. A plus B is equal to 7000 after the transaction. The data is consistent before and after the execution of a transaction. So this example maintains the consistency property of a database. A transaction shouldn't interfere with the execution of another transaction. To preserve the consistency of a database, the execution of a transaction should take place in isolation. That means no other transaction should run concurrently when there is a transaction already running. For example, account A is having a balance of $400 and it is transferring $100 to bank to account B and C both. So we have two transactions here. Let's see this transaction run concurrently and both the transaction read 400 balance. In that case, the final balance of A would be $300 instead of $200. This is wrong. If the transaction were to run in isolation, then a second transaction would have read the correct balance $300 before debiting $100 once the first transaction went successful.